said it a few times now. Kimball. What does it mean? Is he a star? Can I be a star? Can I be a Power BI star? Alright, lads and lasses, welcome along. Kindle schema, yeah, or star schema. What do people mean when they're talking about it in Power BI? It's a really important thing. You're going to have to get your head around what a schema is, and especially what we mean when we're talking about the star schema or Kimball schema. Core part, right? No shortcuts can be taken with this. You've just got to kind of do the work, learn how it's done. What is a star schema? It's not actually that difficult. The main thing to really think about is it breaks down your data into two types of things, yeah? You've got two things in your model, right? Or in your data set, right? You've got events, so something that's actually happened. It's like a thing, right? Invariably, it'll be something that's kind of like intangible, like a list of things, but it's not like a real physical thing, right? And we've got, great example of an invoice, like sales invoice, like sales list, that kind of thing. And then we've got descriptions, right, or dimensions. And those are the attributes that go around there. So for, like, is it all the colors that they've got, or the products that you've got? So if you're looking back at your invoice, if your invoice is the fact that happened, what's on that invoice will be a list of products. You'll have customers tied to it because it's gone to a customer, which might have an address. It's got, there's a lot that goes along with it. And what you can see from the left-hand side of this is we've got a star, haven't we? We've got a fact or the event in the middle, and then we've got the 5 descriptors or however many descriptions you've got or dimensions you've got around the outside. This is something you need to understand. So if it's not making sense, stop and have a think through, right? But let's carry on, yeah? Because what we've done is we've done an example for you. Using the Superstore data set, it does a great job for giving you a nice, simple, basic Kimball schema, right? So what we end up with is 4 tables. We've got 1 fact table and then 3 dimensions. So what we can do, let's cut our into Power BI, switch on the demo view. We'll have a look at that, champion. So here we are, right? This is kind of a schema that you're going to get used to seeing, this kind of a layout for it. We've got a fact table in the middle, and we can tell it's a fact table because if we switch out of if you can see it, right? The stars are all here, yeah? So the many point, all the manys point to one table. Where the manys come to, that's the fact, yeah? Because one row in my dimension is going to relate to many rows in my fact table. So one product is probably going to be sold many times. Does that make sense? I think that's an easy way to think about it. Or one customer is going to buy many products from us. So we start to get this picture of what's going on with it, yeah? Starts to make sense. What we can see as we dig into here is we've got 2 core data set related tables or dimensions here in terms of what customer and what products. And we've got what fact table, what orders, and then we've got the calendar table. And the calendar table is going to be everywhere. Everything you do, you're going to have a calendar. It's very rare that you'll do a project where you won't be using a calendar table. Got any dates in this one? Don't worry, right? Honestly, I can probably count on one hand the number of projects I've gone through where we haven't used dates in any level whatsoever. Really key thing to do. So get used to having your calendar table. It's almost one of them, whacking me calendar table. But they'll put the video for where we've got the calendar build. You can have a look at that. But the core thing you need to understand is the one-to-many relationships here. And this is where we were talking a couple of weeks ago, if you remember, about normality and normalizing your data. And a truly denormalized data set is like your flat file, your Excel spreadsheet. And if I was to open up the Superstore CSV file, which I'll tell you what we can do it from here, come on. You remember back in the video last week, building a base, that's what we've done here. If we come out of the cursor view, we're going to transform the data, right? And again, we've got our base up here, right? And we can see, we're looking at here, you can see this is just one big CSV file, right? But it carries on, right? That's a denormalized data set. So everything is there on one row. Interestingly, right, and this is one that you need to be thinking, need to be aware of, don't need to think, do anything about it, right? But if you're going to do machine learning and all that sort of stuff, denormalized works better. Right? If you're going to do analysis and actually start to crunch your numbers, you need to normalize your data set. So when we're saying normalize, what do we mean? If we look along here, you'll see we've got like customer ID, customer name, the segment, the country they're in, the city, the state, the postal code, the region. Yeah, those all relate to a customer. So what we can do is we can say, well, we're going to create a customer dimension. And that's all we've done. We've taken these rows or these columns, sorry, out, put them in a new table using the reference method, like we showed you last week, right? And because it's a reference, what we can do is we can remove the duplicate customer IDs. So we can see here, we've got this Brashina Hoffman, and she's got all these rows just this one sale, really. So she's had multiple line items that she's ordered. We just need one row for that, didn't we? We just want one row to give her information for that customer ID. So we've done that, which has then given us a customer dimension where we've got the customers. See, we've got one Brashina Hoffman. Okay? That's how it works. You go through, you do it that kind of way, right? By stripping all that out, you've just removed the amount of space that you save in terms of your model storage. You have to see it to believe it. But doing this kind of thing will allow you to take an Excel spreadsheet or a CSV file and compress it right down to maybe 10% of its original size if you get these things right. That's probably where you want to be aiming in my, experience, kind of where it ends up often. But it's always going to depend on the exact shape of your data and the shape it needs to be. But you can see we've done something similar with products because we've got a product ID, which then has a category, a subcategory, and then a product name. So we've now got these built. And what we would look to do is probably build hierarchies in the Power BI file to go with these. We'd have a category, subcategory, product, and we'd have in the customer, we'd probably have a country, state, city, postcode. But we can see we can build and put hierarchies in to make it easier to analyze this data for it. And that's where normalization comes in. So we end up with a consistent usage of United States. Because if the file, the CSV file, had been manually typed in, each time you're going to find that you're going to get to, at the end of the day, there'll be 5 or 10 different spellings for United States. People have just miskeyed it. Likewise for all the others. So normalization is about trying to remove those kind of errors that creep into the system because you normalize it. You're trying to get to the point where we use IDs to build that. One last thing I want to mention to you. If we go and we have a look at the actual fact table that we've got, so the order date table, right? What's left here, right? I hope you can see, with the exception of ship mode, which there's just no point in doing out else with it, right? Because it's just on its own, doesn't make sense, right? With the exception of that, you're pretty much down to just numbers in it. So we've got an order ID. Yes, the IDs are text in this, but IDs, numbers, right? Dates, we know their numbers really behind the scenes in these things. Product IDs, customer IDs, the sales amount, the quantity that was sold, the discount percentage, and the profit. Because you've got all that built in, right, that's something you expect to see in that fact, because that's a fact that relates to it. So the descriptors tend not to be in your fact table. And that's a good rule of thumb. You want to be trying to make sure that your fact tables are as much as possible what we'd call a foreign key. So IDs that relate to something else. So the many side of a join, foreign key, right? Or specifics related to that event. So the sales price that was agreed for it, right? We've then got the discount and the profit amounts that we're making. So what we've got enough here to gan through and build something. The other thing we've got for the purists looking at this, like, oh, wait, yeah, right? I've got an order ID as well, right? Order ID is a useful one for this, right? But often in your fact tables, you'll hear people say, avoid having the ID. So you see, we don't have row number, which is the unique identifier. We've just got order ID, which isn't. And we can see it's not a unique identifier because it's appearing on multiple rows. So this order from this customer contained all these items. So what we could do is we could actually then work out at that order level, are we making profits with these orders, or is something else going on? So we've got all the information there. It's all built. Kimball schema is a big one that you're going to have to learn, right? The Kimball schema, star schema, get used to it. Learn that name, right? And if in doubt, reach out to us, yeah? So hope you've enjoyed that. Don't forget, like and subscribe. For now, take care. Ta-da.